what does it mean for, what would it mean for two binary representations such as this to be prefixes of each other? Well, for example, let's say I had f bar x1 is 0.011010 or something.
The other can be obtained with the shift operation. It's a linear combination of. Can you say it's a one is a linear combination of the other, because if you shift and add something, you obtain the other one. If there's a prefix relationship. Or that's too much stretch.
It's more like there's a prefix relationship if one lies on a particular interval on the real line. So in particular, let's take this. If this is a code word, let's say, then no other code word can start with 0.11. So the interval .011 to 0.11 plus 0.001 is not allowed. In other words, any other code word beginning with 011 is not allowed. So if I have, let's say, any code, let's let these be further bits in the binary representation. I can't have any code starting with 011. So therefore, anything from 0.011 up to, well, it's the same argument as the error. So there's no setting of these that's allowed. So therefore, anything between 011 and 011 plus, basically up to but not including plus 001 is not allowed. Does that make sense?
Which is 1, 0, so.
Yes.
The next.
Or, so more generally, if I have 0.B1, B2, B3, and so on up to BL of X, this is a code word. Then no code word is allowed on the interval. Now I'm going to use the following notation. 0.B1, B2, B3, and so on up to BL of X. Comma, 0.B1, B2, B3, and so on, B L of X plus 2 to the minus L of X, and then round brackets. So I hope you've seen this notation before. If an interval is expressed this way, the square bracket over here means including the first point in the interval, and the round bracket over here means excluding. So this is an open interval notation, so it excludes the final point. But the square bracket over here is the closed interval notation, so it includes the first point. So what I'm going to argue is that, So the claim is that if all code words are replaced by this corresponding interval, then those intervals are disjoint. If those intervals are disjoint, then it must be true that no code word is on the interval of any other code word. Therefore, no code word is on the interval of any other, so the code must be a prefix code. Okay, so to show that, it's helpful to sort of look at a diagram of what we're going to do. So here is f bar. Excuse me, here is f of x. And here are the f bars of x. Now, remember that the quantized points corresponding to f bar are somewhere on this interval for each element. So let me just draw those in. So these x's, those are f bar of x. And these zeros are the quantized elements, which are the code words. So what I'm going to do is I'm going to replace, or I'm going to take these code words and represent them by the interval on which no other code word can exist. So the interval on which no other code word can exist is from binary representation. The interval always starts at the code word and proceeds to the code word, excuse me, b L of x. Plus 2 to the minus L of x. So my question then is, what is the length of this interval? The length of the interval is clearly 2 to the minus L of x. But we already know that 2 to the minus L of x is already the error in the quantization. So therefore, the maximum error in the quantization, which we know is less than p of x over 2. We showed that a second ago. So we know that, we already know that c of x, the code words, are in the lower half of the vertical intervals.